Welcome to lecture 7.1. So, we're taking a look at fundamental trigonometric identities. So these things are going to be important formulas to know and have memorized. So the first ones are the reciprocal identities, and these are pretty much ones we've been working with for a good long time now. Basically, that cosecant is equal to 1 over sine of x, and then so on. So these are all the reciprocals. And then we have the Pythagorean identities. We have also seen these before. They come from a squared plus b squared equals c squared. Also, we have the even and odd identities. We did see these before. So basically, anything that has to do with the y would be considered an odd function. So that is sine and tangent. And then the ones that only have to do with x are even. And that is cosine and secant. Next, we have something new, which are the Co Function Identities. What are these? Well, if we take a closer look at this is basically saying sine. If you have pi over 2 and you subtract some x value from it, you'll end up with cosine of x. So it shifts over the graph to give you cosine of x. Same thing would happen with tangent. Take your pi value, subtract from it, and it shifts it in a way that would give you cotangent. And then so on for the other values. So basically all you're doing is shifting the graph over by some value, and you end up with the new graph. Which makes sense if you think about the graph. So let's see if we have the two graphs here. If we have sine, which usually looks like this, right? And cosine, which starts up here, goes down, and then comes up like that. If we shuffle cosine over some factor, it'll actually end up perfectly laying on top of sine. So it'll look something like that if we shift it over by some factor, and so on for the other ones. Now let's take a look at example 1, simplify. Okay, so how do we simplify? The main goal would be to add the fraction and then see if we can end up with one expression in terms of one trigonometric function. Okay, at the moment, we don't have one expression in one trigonometric function. We have two different expressions in multiple trig functions, cosine, cosine, sine, and sine. So we're going to try to simplify this. How do we do that? We're going to use some of the help of the building up property for adding fractions, as well as some of these identities here. So first off, let's add this fraction to simplify. To create a common denominator, what would we need? Well, the lowest common denominator is going to be sine x and 1 plus cosine of x. So this first fraction here is missing the 1 plus cosine x. So I'm going to go ahead and multiply that in. I have to multiply it to the top as well. Once again, it's called the building up property. Now this fraction here, what is it missing? It is missing the sine of x. So I'll go ahead and multiply that top and bottom by sine of x. Alright, let's see what we get when we simplify. So this will be cosine of x times 1 plus cosine of x plus all over sine of x, 1 plus cosine of x, sine of x. Ooh, sine of x times sine of x will be sine squared x. Careful, sine squared x is not the same as sine x squared, so please watch your notation on that. Okay. Divided by, once again, same thing. So sine of x, 1 plus cosine x. Now, on this next step, I'm going to go ahead and distribute the cosine into the parentheses, as well as combining the fractions. So two steps happening here. So that'll be cosine x plus cosine squared x. And then we're adding in the sine squared x all over the same common denominator of sine x, 1 plus cosine of x. Now we've added the fraction. The next thing I'm going to do is look at any of the identities to see if I can use them to simplify. Well, in the numerator, what do I have? I have a bunch of additions going on. I have cosine x squared, and sine squared x. You know what? This looks familiar. Cosine squared x and sine squared x. That is the Pythagorean identity. If you ever see sine squared and cosine squared hanging out together, that's like a happy moment. That's the Pythagorean identity. Those are equal to numero uno, 1. Okay, so these guys are equal to 1, which means I can sub that out, and I'm slowly getting a more simplified expression. So cosine x plus 1 over sine of x times 1 plus cosine of x. So once again, I substituted out sine squared x plus cosine squared x for 1. And why could I do that? Because it's from this Pythagorean identity right there. And then you might have noticed, but we have the same factor in the top and the bottom. 1 plus cosine x is the same thing as cosine x plus 1, which means these guys can cancel out. And we're left with 1 over sine of x, which at the moment is still not just one trigonometric term. That is the reciprocal of a trig term. So can I simplify that? Let's look at the reciprocals. 1 over sine x is equal to cosecant of x. Let's go ahead, swap that out, and we are left with our one beautiful trig term. So it definitely takes a lot of knowing all of these above items and being able to recognize them in your problem. So please familiarize yourself with these values. It'll make it a lot easier when simplifying, instead of having to continually look them up and compare. If you have them memorized, things will go a lot quicker. So now let's take a look at the next example. We have tangent A over cosecant A plus cosine A and secant A. So you might be saying, well, what is A? Don't worry, it's just a variable in place of, let's say, x or theta. So it's just the variable. One thing to note, though, because they give you a capital A, you are expected to continue solving with a capital A. Or, sorry, simplifying. Well, how would we get this to be simplified? One of the other methods that's good is if you can get everything written in sine and cosine. That is also one of the best, I would say one of the best methods. Writing everything sine and cosine. And at the moment, none of these are in sine and cosine. So let's see if we can rewrite these with sine and cosine. Actually, sorry, one is in sine and cosine. Awesome. So the other two we got to work with. Tangent A over cosecant of A. Do I see that anywhere? No. But I do know that cosecant, that is the reciprocal of sine. So I'm going to go ahead and sort of split this up a little bit. Let me go ahead and bring this in. So this is going to equal tangent A times 1 over cosecant of A plus cosine of A, so that one's already in a good form, and then secant of A. So I'm going to go ahead and want to rewrite, I'm going to highlight the values, this one, and this one in terms of sine or cosine. Now tangent of A, I know that tangent is sine over cosine. And then 1 over cosecant A, well, if I did the reverse of that, that would give me back sine. So I'll have sine over A over 1 plus cosine of A. And then lastly plus, okay, the reciprocal of secant is cosine, so that'll be 1 over cosine. Alright, let's go ahead and simplify this out. So we have a sine A times a sine A. So that'll be sine squared of A. I'm seeing a squared sine. That makes me happy. Maybe I can use the Pythagorean theorem. Okay. And then plus cosine A, that already is a cosine, so that's good. And plus 1 over cosine of A. Okay, so now I have them all written in sine or cosine, which is like what we had starting back in the beginning for the first example A. So once we have them in sine and cosine, the next step is to add them. So we got to create a same denominator, and then we can see if we can simplify. So to make the same denominator, I'll just go ahead and multiply the top and bottom of this one by cosine A, which means I'll end up with a cosine squared A. And now, adding our fractions, we'll end up with sine squared A plus, cosine squared A. Right there we have it. We have one of the identities over cosine of A. So once again, I am always excited whenever I see this. That is equal to 1. So we'll go ahead and swap that out, which will be 2, actually, sorry, jumped the gun there, 1 plus 1 over cosine of A which will equal 2 over cosine of a. But once again, we cannot leave it as the reciprocal. We cannot leave it in the fraction form. It needs to be simplest form. So we'll go ahead and swap this to the reciprocal of cosine, which will be 2 secant of a. And there we go. So don't leave your answer as a fraction if you're simplifying the trigs. Make sure to turn it into just a nice simple trig form. So now we're looking at something that basically is like playing with a Rubik's Cube. Not really, but it's what I think of when I think of these. So these are guidelines for something called proving identities. So basically what happens is, for example, I don't know if you recall, but I have sine squared x plus cosine squared of y equal to 1. And I showed you that you could solve this and end up with one of the other identities. Tangent squared of x plus 1 equals secant squared of x, or 1 plus cotangent squared x equals cosecant squared x. I showed you how to get from this identity to that one in one of the videos. I think it was about 5.3. And I did that by manipulating the beginning equation. Okay, so the same sort of thing happens. That's sort of proving an identity. So we're going to take a look at something similar. So what are the steps? Step 1 is to start with one side of the equation and work your way to the other side. Always write the starting side down. What does that mean? Well, indicate to your reader, which would be me if I'm grading, if you're starting with the left-hand side, so LHS, or if you're starting with the right-hand side, RHS. Okay, this is important. Please make sure to write that down. Once again, something I will be grading for. Next. It's usually easier to start with the more complicated side. Keep that in mind, so the one with more fractions and whatnot. Step 2, use algebra and trig identities to simplify. Once again, that beginning item with all of the different identities, we're going to be using that. And then step 3, if you get stuck, change everything to sine and cosine. Once again, the key, changing to sine and cosine. It's not 100%, but it's pretty good to do. So now let's take a look at example 2. So we're proving the identity. Well, first off, let's identify the left-hand side and the right-hand side. So this is the left-hand side, tangent y, cotangent y, and the right-hand side, secant y, cosecant y. So we're going to pick one of these sides to start with. Which one looks more complicated to you? Well, to me, the one with addition looks more complicated, so I'm going to go ahead and start there. So once again, we are not solving, so don't think we're solving. We're just manipulating an equation to show it equals the other side. So we'll start with the left-hand side. I'm going to go ahead and write that out. So we have tangent of y plus cotangent of y. Notice I'm not going to write down secant y, cosecant y. Why not? Because I'm trying to show that it equals that. I can't just write it down. I haven't proved anything. So I need to work with some trig identities to slowly work my way to the right-hand side. What does tangent y and cotangent y equal? Well, if my plan's correct, it's easier to rewrite these in sine and cosine. So I know that cotangent and tangent do equal some values of sine and cosine. So we're going to go ahead and swap to sine and cosine, because that is pretty much a really useful thing to do. So tangent y is going to equal sine of y over cosine y, plus, and cotangent y is cosine of y over sine of y. Okay, so we've written them in sine and cosine, which is the plan. Now do you remember the next step? The next step is to get rid of the fractions and combine them into one fraction. So we'll go ahead and build these up to create the same fraction. And I get sine squared y all over cosine y sine y plus cosine squared y all over sine y cosine y. Let's go ahead and add these together. Still not looking much like what we're trying to find, but I am ever so hopeful. Okay, so once you've done that, pause a minute and take a look at what we have. Ooh, I see it. Do you see it? I hope you do. It's something I said to look out for. We have our lovely couple, sine squared and cosine squared y, which we know equal 1. Aha. So we can rewrite that. That'll be 1 over cosine y sine y. Are we any closer to making this equal to secant y cosecant y? Hey, if you remember, secant and cosine are reciprocals, and cosecant and sine are reciprocals. So if I rewrite this to 1 over cosine of y times 1 over sine of y, and I take the reciprocals, that'll be, so the reciprocal of cosine of y is secant of y, and the reciprocal of sine y is cosecant of y, which is exactly what I was trying to solve for. Hey, we've gone from the left side to the right side. Awesome. So once you have gone to that side, what you're going to do, there are a few ways to indicate that you finished your proof. One of the main ways is to just fill in a little black box. Okay. Once again, notation is something I do grade for because that's a way of communicating with me that you know the math. So you could do the little black box, or the other one is QED, which stands for Quod Erat Demonstrandum, which sounds like a Harry Potter spell. Basically, QED, Quod Erat Demonstratum, means what was to be shown. It's Latin. So you're saying, I have shown what needed to be shown. So you don't need to write that out. You could just write QED. Or in Hawaii, once again, what is acceptable is to write POW. You are allowed to write POW for proofs. Okay, because you all finished. All right, so there we go. We have finished one of our proofs. Awesome. Give yourself a little high five. Now let's take a look at 2 more. B. So what's our plan again? First plan, start with the side that looks most complicated. Change to sine and cosine if you need to. And work your way to the other side. Looking at this, which one looks more complicated to you? The left-hand side or the right-hand side? I'm hoping you said left-hand side, because that is technically considered the more complicated one. So let's go ahead and start on the left-hand side. Once again, we are proving, not solving. So left-hand side, 1 minus cosine squared theta times 1 plus cotangent squared theta. And we're trying to see if we can make this equal to 1. So we don't have fractions to add, but we do have these 2 parentheses that look a lot like we could do some FOIL with it. So I think I'm going to do that, but before, I'm going to make sure that I have everything in sine and cosine. So at the moment, this one is not in sine or cosine, so let's go ahead and change that. It'll be 1 minus cosine squared theta times 1 plus, and cotangent squared theta. We could rewrite that as cosine squared theta all over sine squared theta. Where did that come from? Let's go ahead and find that. It comes from basically squaring both sides for this equation here. If you square one side, you'll get cotangent squared x, and then squared and squared. So it's sort of built off of that one. Alright, so we did that. So now, I want to see if I can simplify this any further. So, I have all these pluses and minuses. Let's see if I have any of those in my identities. You know what? I have a 1 and a cosine in my problem. So I wonder if I can simplify with this. Let's go ahead and check. So I know, by the Pythagorean identities, that sine squared x plus cosine squared x equals 1. And then I could solve for sine squared x by minusing cosine squared from both sides. So I'll get sine squared of x equals 1 minus cosine squared of y. Or sorry, of x. Which is exactly what we have right here. So let's go ahead, we can simplify now. We'll substitute that out for sine squared of x. How did we find that? Once again, we used the Pythagorean identity and just manipulated it a little. So one thing to note, for the proofs, a lot of it is kind of guessing and checking. There's a lot of trying new avenues. Sometimes it doesn't work out. You got to go back. It's just because there's so many identities to use. But don't give up. Keep persevering. So then we have sine squared of x times 1 plus cosine squared theta over sine squared theta. You might say, well, can we use an identity to substitute for this value here? We don't have any of the identities that have a fraction going on like that, so that's probably not going to work. So the next thing I could think of, let's go ahead and multiply these out and see what I get. Because I have a feeling that sine squared is going to cancel with the other sine squared. Oops, I wrote x. That should be a theta. Okay, so when I multiply that out, I'll get sine squared theta plus sine squared theta cosine squared theta all over sine squared theta. Those guys will cancel out. And we'll be left with sine squared theta plus, ooh, look at this, sine squared theta plus cosine squared theta. What does that equal? Hopefully by now that is just sort of grilled into your brain. That is equal to 1. Awesome. There we go, 1. And then how do we answer once again when we're done with the proof? Either use your box, or you can do QED, or you can say POW. Either one of these works, but once again you need to state to me that you know the proof is done. That is why I ask that you state one of these. Because if not, I'll be like, huh, did they know it was done? Alright, so go ahead, try C by yourself, and then check in with me in a second. Okay, so hopefully you gave this a go. Now let's take a look. Which one is the left and right side, sorry? Left side, right side. Which one looks more complicated? Well, actually they both kind of look complicated. But the right-hand side is still written in secant and tangent, which makes it more complicated than the other side, which is just written in sine. So I'm going to go ahead with the right-hand side. So we'll start with secant of x minus tangent of x squared and see if we can end up with the left-hand side. So my plan, let's write this in sine and cosine. So secant, written in sine or cosine, would be 1 over cosine of x. And then tangent would be written as sine x over cosine of x squared. Hey, what do you know? They have the same denominator. So we can go ahead and rewrite this. So that'll be 1 minus sine x over cosine of x. Still squared. Nothing else to do on the inside, so we can go ahead and distribute that too. So we've got minus sine of x squared over cosine squared x. One thing once again to note, that 1 minus sine of x squared is not equal to 1 squared minus sine squared x. Okay, it is not. What is it equal to? It is equal to 1 minus sine x times 1 minus sine x. Okay, it's got that binomial. So let's pause a moment here. What is my goal? What am I trying to get to? I'm trying to get to this value here. And notice everything here is written in terms of sine of x. And it has that 1 minus sine x value. So I know these two guys are pretty close to what I want to get to. But that cosine squared of x, I don't want that. I want sine. So can I swap cosine squared x out somehow and replace it with sine? I can. If you recall, the equation that has sine and cosine in it is that one right there, one of the identities. Let's go ahead and solve for cosine. So cosine squared x equals 1 minus sine squared x. Aha! We could rewrite it in terms of sine, which looks a lot closer to the left-hand side. So let's go ahead and swap that out, replacing cosine squared x with 1 minus sine squared x. Ooh, we're getting way closer to what we want. But we don't want that binomial in the top, or we don't want those two binomials. Is there a way to cancel one of them out? And there is. If you'll notice, this right here is something called the difference of two squares. If you have a binomial a squared minus b squared you can factor it into a minus b times a plus b. So let's go ahead and do that. 1 minus sine x times 1 minus sine x, and then factoring the bottom, which once again, that is one of the algebra skills. So if you need a review on any of that, let me know. I'll do 1 minus sine x times 1 plus sine x. Can we cancel? Aha! We can cancel those two. And we're left with something that looks exactly like how our answer should look like. Or not our answer, sorry. The right-hand side. Or actually the left-hand side. Look, we found the left-hand side. So we're done. We can write POW, our little filled in black box, or QED. So once again, what helped with this one was recognizing the fact that I wanted to end up with only sine values. That really helped figure out that last step right there for getting rid of that cosine. Alright, so that's the practice problem. Once again, those will be uploaded for you by the end of the week, and that is it for section 7.1. Please email me if you have any questions or want another explanation on any of the examples from this section.